Let's talk about a concept that's huge in calculus, the tangent line. In this video, we'll focus on three things: the definition of the tangent line, how to find the tangent line for any curve, and what it means for the tangent line to be horizontal or vertical. We're covering these topics in particular because they're some of the most important things you'll need to know about the tangent line if you're taking Calc 1. So what actually is the tangent line? Well, it's a line that is tangent to a curve, meaning that it touches the curve at just a single point, and then continues in either direction with exactly the slope of the curve at that point. Notice that the tangent line isn't parallel to the curve itself, its slope just matches the slope of the specific point on the curve. One way to remember this is to think of an expression you've probably heard, going off on a tangent. That's where somebody in a conversation starts off by talking about something related to the conversation, but then totally diverges from the topic at hand, like maybe one of your relatives does over holiday dinners, no matter what topic of conversation was, or what they're eating, or... Anyway, the tangent line is super helpful because it can tell you the rate of change of a curve at a specific point on its graph, as long as you know the equation of the tangent line. You can find this equation a couple of different ways, depending on the information you've been given. The first way only requires you to know a point on the curve and a point through which the tangent line passes. From there, you'll just need to use the point-slope formula to determine the equation for the line. This way of figuring out the tangent line doesn't require that you know the equation of the curve or even what the curve looks like. It could look like this or like this. But if you're given the equation for a function, you can use the derivative of the function to find the slope and then the equation of the tangent line at a given point. To do this, you'll first need to pick a value of x and determine f of x. Let's use x equals -4. We can determine that f of -4 is 2, because when we plug -4 into the function, we get -4 quantity squared plus 5 times -4 plus 6, and that's going to simplify to 16 minus 20 plus 6, which is going to give us a positive 2. So the point on the curve that the tangent line will touch is -4, 2. And now we just need to know the slope of the tangent line that'll pass through this point. Luckily, we know that the slope at any given point on the function is given by the derivative of that function. At x equals -4, the derivative of the function is equal to -3. Now we can use all this information to plug into the point-slope formula, which will give us the equation of the tangent line. And so for the equation of the tangent line, we're going to get y minus 2 is equal to -3 times quantity x plus 4. Sometimes in your calculus career, you may be asked to determine where on a given curve the tangent line is either horizontal or vertical. These special cases can give us some information about the behavior of a curve or function. Here's a function that appears to have a horizontal tangent line pretty close to this point. To be sure, we can look at the derivative of the function and determine where it's equal to 0. We'll get the derivative 3x squared is equal to 0, divide both sides by 3, and then take the square root to get x equals 0. The derivative at a point will be equal to the slope of the tangent line at that point, and a tangent line with slope 0 will be totally horizontal and therefore parallel to the x-axis. So a function will have a horizontal tangent line anywhere where its derivative is equal to 0. A vertical tangent line, on the other hand, aligns with a point on the curve at which the slope is infinite or exactly vertical. This function, for example, appears to have a vertical tangent line here. An infinitely steep slope means that the derivative along this line is undefined. So to find out exactly what this line is, we need to see where the derivative of f of x is undefined. We know that any function is undefined where its denominator is equal to 0, so we can simply set the denominator of the derivative equal to 0 and solve for x. We'll start by dividing both sides by 3, which will cancel the 3 on the left-hand side and still just leave us with 0 on the right-hand side. Then we'll raise both sides of the equation to the third power to get rid of the third root on the left. That'll leave us with x minus 2 quantity squared equals 0. Then we'll raise both sides to the 1/2 power to cancel the exponent on the left. That'll leave us with x minus 2 equals 0. We add 2 to both sides and get x equals 2. So the graph of f of x has a vertical tangent line at x equals 2, which means that it's parallel to the y-axis. So a continuous function will have a vertical tangent line anywhere where its derivative is undefined. Let's summarize everything we now know. The tangent line intersects the curve at the point of tangency, and the slope of the curve at the point of tangency is the same as the slope of the tangent line through that point. Horizontal tangent lines exist at any point where the derivative is equal to 0, and vertical tangent lines exist at any point where the derivative is undefined.